Factoring out the greatest GCF means looking for the greatest factor that evenly divides into an expression and then undistributing that. So we often think of this as the opposite of distribution. Here's what I mean. Let's look at the example right below. This says, okay, 4 times x plus 2. We've done that before. We know that means distribute. So the 4 multiplies the x to become 4x, and the 4 multiplies the 2 to become positive 8. And so that's multiplication. When we have that answer, 4x plus 8, and we're asked to factor it, we're being asked what was distributed to create this answer or create this expression. And that process can be a little bit more complicated than the multiplication process. So here's what I like to do. I take each of the terms and I write them out specifically. And then I look at the numbers first, and I look at 4 and 8. I'm thinking, what's the biggest number that evenly divides both 4 and 8? Well, that would be 4. And then I look to see if they have any variables in common. The top thing has an x, but the bottom term does not. So really the only thing they have in common is a 4. Now I have to figure out what was this distributed to. So looking at the top, I've got a 4. What would I need to multiply 4 by to create that 4x that we have in the original problem? Well, I would need an x. In the bottom one, I have 4, and I need to get back to 8. Well, if I multiply by 2, that would get me to 8. That tells me that this 4 is the thing they had in common. It's what was distributed. And the x plus 2 is what the 4 was distributed to. This is the factored form of that expression. And notice, it's exactly the same as the problem on the left, the one we were asked to multiply in the first place. So we're going to follow this process through a little bit. We're asked to factor the expression 7x minus 21. So I've already taken the 7x and the negative 21 and written them separately. So now it's time to look and say, well, what number is the biggest number that evenly divides both 7 and 21? And that would be 7. I see an x in the first term, but not in the second term, so they don't have x in common. So it's time to figure out what's missing. Well, 7 times what would give me 7x? Well, there's an x missing. And 7 times what would give me negative 21? Well, that would take a negative 3. So this 7 is what must have been distributed into the problem. And it must have been distributed to an x minus 3. That's the factored form of that expression. Let's look at this next one. This one's longer, and I've again already taken the 3 terms and written them out for you. So we've got 36, 24, negative 24, and 8. And we're looking for the biggest number that evenly divides all 3 of those. Now, my first instinct is to say 8 because I know 24 is divisible by 8, but 36 is not divisible by 8, so 8 must be too big. So the next factor down in 8 would be 4, and 36, 24, and 8 are all divisible by 4. So that must be the biggest number that each of these numbers can be divided by. And then I always want to check my variables. And this time, notice there's at least an x in all 3 terms. So they also have an x in common. That's the first time we're seeing that on this note sheet. Now I need to look and see what's missing. Let's start from the bottom and work our way up because it'll be less complicated. So I've already got 4x and I want to get back to 8x. Well, I just need to multiply by 2 to get myself there. Looking at the middle one, I've got 4x. I need a negative 24x squared. Well, to get the negative 24, I would need a negative 6. I've already got x. I need x squared, so I need another x to get me there. And then doing the top one, 4 times 9 is 36. And I've got an x. I need x cubed, so that means I need an x squared. So the 4x is what someone distributed to get this problem. And they distributed it to a 9x squared minus 6x plus 2. And that's the factored form. Okay, we're going to take a look at one more thing together. And this is, we're going to start with multiplying, and then we're going to look at factoring and how that's related. So let's write this out the way we've been practicing multiplication problems previously. So we know that first we would have to take that 3x squared and distribute it to an x plus 5. And then we would have to take the minus 2 and distribute that to an x plus 5. So that's the first line that we write. Then we can do each of those two distributions. So 3x squared times x is 3x cubed. 3x squared times 5 is plus 15x squared. Negative 2 times x is negative 2x, and negative 2 times 5 is negative 10. We check and we see that there aren't any like terms, so that cubic polynomial in 4 terms is the result to that multiplication problem. Now, if you notice, that's the same problem that I'm asking you to factor in the next column. So we already know that the answer is going to be that multiplication problem. The question is, how do we get there? This process of factoring a big polynomial like this can be a little bit more involved. It's not just factoring out a GCF. In fact, if you look at 3x cubed, 15x squared, negative 2x, and negative 10, there aren't any GCFs for those 4 terms. So I can't factor out a GCF. It's a bigger type of factorization. So if you look off on the right, there's a list of steps. First is to look for what we call the big GCF. That would be a greatest common factor for all 4 terms. And this problem doesn't have one. So now we go to step 2, which is solve the puzzle, usually. This is for something with 3 terms, but we have 4 terms, so we get to skip that step as well. Split the middle term comes from the puzzle, so I'm again skipping that step. And now I'm ready to go straight to this step. As soon as I have 4 terms, I actually go to step 4, group to create a sum. So here's what we mean. I need pairs, because if you look back at that multiplication problem, see how the first 2 terms are grouped and the second 2 terms are grouped, right? Something was distributed to 2 terms, and then something was distributed to another 2 terms. We're trying to create that situation. So I'm going to put parentheses around 3x cubed plus 15x squared, and it says to create a sum. Remember, sum means addition. So I've got negative 2x minus 10 in the second set of parentheses. So that's what we mean by step 4. Oh, sorry, this is a little, my computer's not cooperating. There we go. That's step 4, group to create a sum. The second says 2 GCFs. So that's what we were doing up above where we found the GCF. So I'm going to use the space down below. 3x cubed and 15x squared. Well, they're both divisible by 3, and they both contain an x squared. To get back to the original terms, the top one would need an x, and the bottom one would just need a 5. So the 3x squared is what we're factoring out, and x plus 5 is what would be left inside. Then for the other 2 terms, negative 2x and negative 10, well, notice that first term in the pair has a negative, so I'm going to pull a negative 2 from each of them. They don't have any variables in common. The top negative 2 needs an x to get back to its original, and the bottom negative 2 needs a 5. So the GCF to pull out is a negative 2, and x plus 5 will be what's inside. All right, then there's a binomial GCF. The binomial GCF is what binomial do they have in common? And notice both the first half and the second half have an x plus 5 in common. So we can actually factor out the GCF of x plus 5. They have an x plus 5 in common. Well, when I take the x plus 5 from the first term, that leaves me with a 3x squared. And when I take the x plus 5 from the second term, that leaves me with a minus 2. Now I have factored this thing into the product of 2 binomials. That is the factorization of that 4-term polynomial. And notice, that is in fact the problem on the left that we did to get this answer in the first place.